Alexis, how many did you do?
I kind of just did like scattered questions, but
Okay.
for this one, I got one sample Z test. I was choosing between that one and the T test, but I'm not sure.
I got D.
D?
I got D only because I was going by this flow chart.
Oh.
Okay, so there's an article of the Journal of Small Business Success Stories in the United States and Korea were compared. So there's two groups being compared, right?
Mm-hmm.
Okay, and one set of data compared educational levels of people who manage successful startup companies in the United States and Korea. So there's two groups that are being compared. You want to determine if the education level differs between the managers of successful startup company differs from these two. You know what though? This is more of a categorical question than a quantitative.
Yeah, I think I did it wrong.
So when I looked on my chart, we have two groups. Like on this flow chart, we have two groups, and the two groups are not dependent on each other, I don't think, but they could be dependent on each other. Meaning, if you have somebody from Korea, you have to have somebody from America, but I think it's an independent one. So I went by two groups, and the groups are independent, so it's a 2 sample T procedure.
Mm-hmm. And I almost did sample T, so that makes sense why it would be an independent sample T.
So you think it might be D?
Yeah, I know. I trust you way more than I trust myself.
I don't know. I'm just talking myself through it. So Cassie, on those kind of questions, these flow charts really help. Okay. But I don't know if we're doing it right, but we'll see. Okay, Alexis, what did you see? A, B, C, D. Alexis, what did you get on number 3? Oh no. I guess it's number 2 on the.
I know this confuses me because like they're off.
That's because question 1 online is if we participated.
Mm-hmm. So it throws it all.
Yeah.
I'll read it really fast and I'll see. 1 sec.
So what did you get on number 3 then? Or 2 on the paper?
I skipped that part because I was doing the other parts.
Okay. So
because I'm running out of time.
I think it's C. I think it's C. Paired samples.
Let me read it.
I think.
Your attorney. Yeah, that should be that should be paired.
Because there's one group that's under 40 and one pair and over 40.
That's over 40. Mm-hmm.
So,
and then you're comparing them.
Yeah. So if you have one group that's under 40, the other group has to be over 40. So I'm thinking it's paired. Ugh. I don't know.
I hope.
We'll just see. Okay, the next one. A survey was conducted by a group of state lotteries. A random sample of 246 adults completed the survey. A total of 246 were classified as heavy players, and of these, 152 were male. You want to determine their proportion of the male heavy lottery players is different than the proportion of males, which is 48.5%. So the key word there is proportion.
Yeah. So I think it's 1, right? 1 proportion.
I did, yes, test of 1, A, B, C, D, E, F, test of 1 proportion.
Okay. Perfect.
We'll see. And then the next one, a student project compared the effectiveness of two different combination locks. One lock turned clockwise and the turn counterclockwise. Asked 25 students participate in each study. Each was given a combination to each lock and asked to open the locks. And they took the time. What do you determine if one of the locks is easier to open? Which hypothesis test would you use?
Let me look. Would it be paired again?
I think it's paired because you've got the same, but you've got the same lock. No, you've got one lock that goes clockwise and one lock that goes counterclockwise. So wouldn't they be paired?
And then you're just comparing them, which is easier.
I think that's it. I got these wrong on my homework though, so.
Okay.
A bank employs two appraisers when when approving buyers for mortgages. It is imperative that the appraisers value the same types of property consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence level? So let's see.
This one's so hard.
I think I did D on this one because independent samples. So I looked on my little thing here. You have 2 groups, right? No, you have 2 appraisers. You have 2 appraisers, and they're comparing them. So I think it's independent sample t-test, I think.
I think that seems right, because looking at this flow chart, that seems the most appropriate.
I don't know. These are the most confusing to me.
I'm going to get these wrong in the test. I just know it.
Okay, question number 7. I put A, B. I put C. Did I put C again? Paired samples again? Ugh. See, that's got to be wrong.
Let's see. Wall Street Journal. But that's what I would do because it's kind of like the same kind of question from up above. Career path.
But really, they're not paired because it doesn't matter like what psychologist and what.
Oh, you're right. Look at the flow chart really fast.
So you've got flow chart. You've got 2 groups, but I think they're independent. So 2 sample t-test, but that's not even one of the.
Yeah, because for 2 groups is paired T or 2 sample T.
But that means independent sample t-test is what that means.
Yeah.
I'm going to put A, B, C. I'm going to put D on that one, I think.
Yeah.
Okay, and then number 7, or what, 8 on the thing. Double stuffed Oreo cookies are supposed to have twice the filling. You and some friends decide you want to know if it's true. You sample 55 and take the measurements. You need to construct a confidence interval to estimate the true mean filling.
Would it be E?
I put B, but
because are we looking at confidence interval?
We're looking at
crap.
I put.
Okay.
You know what? There's only one group. There's only Oreos.
Mm-hmm.
And we don't know the sigma. So it'd probably be a 1 sample T.
Let me look at the 1 T. Oh, yeah. You're right. Because sigma is unknown for sample T in the chart.
What's that?
Yeah, you're right. Because in the chart for the sample T, the sigma is unknown.
Right.
I think you're right. The sample T.
Okay. Did Cassie leave?
I don't know. She went off.
Okay. So which of the following best defines the notion of the significance level of a hypothesis test?
I put C.
Okay.
What did you put?
I had no idea on that one.
I think that's true.
The probability of rejecting HO, whether it's true or not.
Yeah.
Wait a minute. I'm getting messed up here. 8, 9. Which of the following best defines the notion of significance levels? And you put, what did you put?
C, the probability of rejecting HO, whether it's true or not.
Okay. Wait a minute.
Because that's the significance level. We use that to compare against a P. And then from that comparison, we decide to reject or not, right? That's what I think.
Yeah, it seems like I missed that on the homework, but. Okay, let's go to number 10.
I put A.
Okay, suppose you create a 95% confidence level for a mean. Oh, wait a minute.
Oh, wait, 10?
Sorry. I'm getting mixed up.
This one is, which of the following best defines the notion of the p-value of a hypothesis test? And so I put the probability of a type 1 error.
Okay, I don't know on that one. I honestly don't know. So you put type 1 error?
Yeah. So it should be A on the group quiz online.
Okay. All right.
Hey, you're back.
Sorry, my dog started freaking out, so I didn't want you guys.
Okay.
Are you fine?
Okay, now the next couple questions. Okay, so the next question is, suppose you create a 95% confidence level for a mean and get, 10 as the lower and 20 as the upper. You've been told to report this by saying something like, we are 95% confident the true mean is between 10 and 20. Exactly what does that mean?
So I get confused on this one, but I put B. 95% of all 95% confidence intervals actually contain the true mean. But I could be wrong.
That's what I put.
Oh, okay. And these next ones, I had no idea how to do.
Okay, I did not know how to do the next one either. You take a simple random sample of 100 adults from a town in the Western United States, determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equals 0.30. What is the mean of the population? I thought 0.30 was the answer. I thought the mean
because P equals that.
Yeah, that's what I thought.
Okay, well, let's just go for it.
Okay. Now, what is the standard?
Because in my notes, I have P equals that. But
what is the standard deviation of the distribution of the sample proportions?
I had
No idea.
Let me look at the review.
I've looked everywhere in the review, and in the textbook it gives us 4 options for number 12, and I cannot. Huh?
I'm gonna look at that really fast. Oh yeah.
In the textbook, but none of my. It's supposed to be like.
So we're looking for the distribution.
We're looking for what is the standard deviation of the distribution.
Okay. So is it the equation? Wait, sorry, what, Cassie?
Is the standard, which standard deviation population minus 1? That's degrees of freedom. Scratch that.
Well, on the, I don't know if this is right or not, but on the lesson review, like recap for lesson 16, it has the sampling distribution of p hat has a mean of p and a standard deviation of, and then I'll show you the equation really fast. Oh, wait. Is that it?
Well, let me try. So we do P, which is 0.30 minus 1 minus 0.30 equals -4 divided by 100.
And then square root it.
Hang on. Okay, so that's what on number 12, one of the answers is 0.0004.
Oh, it is? Yes. Should we just try that?
Yeah. Okay, so you got that by going, so write that down, Cassie. Oh, where'd she go?
Here, I will put it back up. 1 sec.
P minus 1 minus P over N. Oh, wait a minute. Let me do this again. Did I do that right? 0.30 minus 1 minus 0.30 equals, and then divided by 100 equals that, and the square root of that. Okay, so Cassie, you might want to write that down on your notes. If you, like on number 12 on the textbook, the standard deviation was P minus 1 minus P over N, square root that.
Yeah.
So it's 0.30 minus 1 minus 0.30 over 100 squared. So then if we go to our applet and we put in 0.004, Okay, but then what is the probability that your random sample of 100 adults will have the same proportion less than 25%?
Sorry, I don't interrupt, but what did you guys?
I'm sorry, say that again, Cassie.
I said, what did you guys get for 13?
We got 0.0004.
I got a different answer. Is 0.04 0.058.
Oh, how did you pick
Yeah,
that?
it's 0.004, right?
I don't know because what she said is one of the answers too.
So if you type in, this is one of the things of order. So
yeah,
in math, you have the order of math. So you have to do it in the parentheses first. So you would do 1 minus p, then you would times that by get the answer, and then divide it by 100, and then take that answer and square root it.
You're right.
okay.
Because
So
if you just type it into the calculator like that, it'll come.
Cassie?
Mm-hmm.
Not Cassie. Just show me that formula again.
Me?
Yeah.
Yeah, 1 sec.
Was it P minus? P minus 1.
Is
So
minus or time? I can't.
So Cassie, you're saying do 1 minus P first, right?
Yeah.
1
And then equals
minus 0.30 equals 0.70.
Mm-hmm. Times 0.7 times 0.3, right? So you go time, yeah, 7 times 0.3. Right? Is that
Why
a
do you times it though? It says P minus, not times.
It's really blurry. I can't tell if that's a
So
Alexis, does that say P minus or P times?
So in the equation, it has P times the parentheses 1 minus P.
Okay, I thought it was a minus.
Yeah, so it's P times parentheses 1 minus P divided by N and the square root.
So that is 1, 2, 3. So 0.1. Point. I'm not doing this right.
So what you do is go 1 minus P. So
1
point.
minus point is 0.70.
Yes. Then you times that times 0.3 equals
0.21.
Yep. Then you divide that by
100.
Mm-hmm.
Right?
Yep.
So you doing that brings up a 3 zeros in front of the 2. So that answer is 0.0. Oh no, it's 0.0021.
Yes.
Okay, I put one too many zeros in there.
And then you square root 0.0021.
So the answer would be 0.046, which is one of the answers.
Okay.
See, you're doing much better than you think you are.
Yeah, you were good.
I can't remember or I don't know, apply know what equation, I can read the equation.
Okay, so when I put 0.046, so then do you put that 0.046 into the applet to see the probability?
Mm-hmm.
Does that go in the zero or
no, because because I don't know where the less than 25 comes in. So do you put 0.25 in the applet? Oh, yeah. I don't know about that one.
What are the options in the review? Like in the...
Yep. So options are 0.138, 0.124, 0.76, 0.862.
Gosh.
Could you read that again?
What's that?
Could you read those again?
Yep, 0.138, 0.124, 0.876, 0.862.
And then what's it asking? Less than 25?
It's asking, what is the probability that your random sample of 100 adults will have a sample proportion less than 25%?
Okay. I'm just going to fiddle around and see if this is...
So I wonder if you put 0.25 in the area.
Uh-huh.
No, that's not it. That's not one of the questions. That's not.
Yeah, I'm not getting any of these answers that... Well, how do we find the z-score? Maybe if you find the z-score, then we can do it.
Oh, that's probably right. Find the z-score. Okay. Let me go back in my notes here to find how to do the z-score. Okay, let's see. Okay, the z-score is the total minus the mean divided by the standard deviation. So we know the standard deviation is 0.046, right? So it's maybe 100 minus the mean, which is 0.30, over the standard deviation, which is 0.046, maybe? I don't know.
What was
Let's
that
try.
equation again?
What's that?
What was the equation for that?
Well, let me try it first, because I'm probably completely wrong. You know, but the problem is that proportion less than 25%. That 25% has to come in somewhere. I don't know. Should we skip that one?
I don't know.
And come back, maybe come back to it?
Yeah.
Let's come back to it. Oh, did Alexis leave?
Oh, she probably got kicked out again.
Okay. Hang on. I need to send a text real quick.
Okay.
Sorry, my phone died, so I'm charging it right now.
Okay.
So
okay,
I think we need to find the z-score.
Well, the problem is, even if we found the z-score, how would you do the 25%?
You put that in the area box, I think, and then we put our z-score where that goes, and I think it might end up, but I'm not sure. We could try.
Okay, how do you?
So the standard so the z-score equals p hat minus p divided by the standard deviation, which we already have. So to find p hat, it's x over n. So I think we can find it.
Oh my gosh. So our standard deviation is 0.046. Let's see. 0. Right.
K. And then p hat minus p. So p is what? I forgot. 0.30?
It's 0.30.
And then we have to find p hat, which is x over n. So n is what? 100?
Yeah.
And then what's x?
I'm guessing 30%.
30%? Okay. And then, okay. So let's just see what comes out. Get my calculator.
That doesn't look right to me, but I could be wrong. This is so frustrating.
I know, isn't this so? Okay. Minus 0.30, enter, divided by 0.04.
But you know what, Alexis?
Yeah.
If we're going to do the z-score on this particular one, I don't know that we use p hat and p, because this formula came way before we learned about p hats.
Oh, that's true. Ugh, I don't know. I don't like how these are all cumulative.
I have that the z-score is x minus mu over the standard deviation. So I have z equals 100 minus 0.30 divided by 0.46.
Okay, let's do that. So 100 minus 0.30 divided by, so that, oh, I got a huge score. I mean, a huge number.
93.478.
Oh, no, oh, never mind. I did something wrong. Wait, so what'd you get?
I got 93.7478.
Oh.
So it was 100 minus 0.3 divided by 0.046. I got like 2,000.
See, I got 2,000 as well, so I think I'm definitely wrong.
You have to hit equal every time, or else it doesn't come out right.
Because I got like 2,167.391304.
Yep.
But
okay, I'm skipping it. Let's keep going. Today's my husband's birthday. I got to go out to dinner with him. I'm not. This is silly.
I agree.
Let's go into the next one.
Okay.
So we do not have an answer for that.
You know what? Let's each put it in one of the options from the review and just do that.
Okay.
So I'll put 0.138.
Okay. Cassie, what do you want to put?
Whichever one.
You put 124, okay?
Okay.
I'll put 0.876. Even though we're not going to know how we got it, so.
I know, that's just frustrating.
Okay, so the next one is this thing about create a 95% confidence interval for P1 equals minus P2. Input the margin of error.
Is this for a 2 proportion?
Yeah.
Okay. So let's put that in.
I did this one, but I don't know if it's going to be right or not.
Cassie, let's put it in and see if we get the same answer as she does. Okay,
Yep.
so for X1, it would be, what, 61?
Yep.
Okay, and then N1 would be, where am I? 579?
Well, isn't N1 the 1563?
Oh.
The first one, the first group was given the medicine. And there were 1563 subjects that got medicine.
So wouldn't it be the 61, the total in the experiment group, which... Yeah, you're right, Lori. Yeah. So 1, 5, 6, 3. Okay. And then
that's how many were.
So then 15 is X2, and then 579 is N2. Okay.
That's what I put.
And then the type of test, we are looking, let's see. Is it going to be...
You know what? This, oh my gosh, the online test question is not the same as the textbook question.
It's not?
Nope. Because on the online thing, question 17 says of error for this 95% interval. And
that is question 15 on the online one.
I know. It's not on the textbook one at all.
Oh. Oh my. Okay.
So what you do for the margin of error would be the upper bound minus the lower bound.
Divide by 2.
Yeah, what is the lower bound?
Wait 1 second. So for the type of test, did you put greater than, equal than, or less than?
I just put equal.
Okay. So let's see what I get. I'll do the calculation really fast. So okay. So 0.029 minus negative 0.003. So I got 0.016.
For the lower bound.
Negative 0.003.
Okay. And the upper bound is 0.029.
Yep.
Okay, so the margin of error would be, let me see, negative 0.003 minus 0.029.
So do the upper minus lower. So the upper bound is 0.029 because it's bigger than the 0.003.
And divided by 2.
Is it? I thought it was just upper bound minus lower bound.
Yeah, it's divided by 2.
0.016, is that what you got?
Yes.
So Cassie, it's the upper bound minus the lower bound divided by 2 is the margin of error.
Okay. And then we put just those in for the next couple answers. The low and upper. Okay. So now perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects who do. So the level of significance is 0.05. So we're looking to see if they're different. Okay.
You have to first write the hypothesis test. And the thing is, it's not greater than or less than. They just want to know if it's different.
So would it be A?
Yes, it would be A, because if the hypothesis test is P1 equals P2, then the alternate is P1 does not equal P2.
Perfect. Now once our test statistic.
What?
Yeah, do you see where the test statistic is?
Isn't that 1.458?
Yes, that's what I got.
Okay, and then the p-value is 0.145.
Yes.
Okay, and then now we have to decide. Okay, so since the p-value is more, we're going to fail to reject, which means that we have insufficient. So we're going to fail to reject HO.
Right.
So let's see. Okay, so that would be D.
No. You
it's the very last one, right?
Yes. I failed to reject.
Okay.
Now this next group, you can put in one of those chi charts.
Which I did this question, so hopefully I got it right.
Okay.
So for
let Cassie fill in her information first if she wants.
Okay, perfect.
Okay, so do we just go straight across? One.
Yeah. So when you fill it in, like column 1, column 2, column 3, column 4 would be the 97, 177, 210, 210.
Okay.
So Cassie, what did you get for your test statistic?
0.5. Is that wrong?
Did you fill in that little Kelvin number? Cassie?
Input.
What's that?
So I have in row 1, 97, 177, 10, and then in row 2, I have 131, 167, 200, and 190.
Perfect. Okay, so then look to your right where it says chi-square test, and what do you have in the test statistic square box?
6.579.
Yep, that's what I have. I have 6.579.
Okay, well, okay. Okay. Let's do that. In the textbook, that is not an option. 6.580 is an option, but I'd rather go with what's on the chart.
Yeah.
Okay, and then what is the p-value?
I got 0.087.
Mm-hmm.
Okay.
0.087, right?
Yes. And then 24, I got D.
Yeah.
Because the p-value was greater, so then we're not rejecting.
Yep.
And then for 25, I got C.
Hang on. Why do you conclude?
But I was confused between C and D, so I may be wrong.
So we have insufficient evidence to say that being a morning person is okay, let me look real quick on my notes because I remember. Okay. Okay, if it is the null hypothesis, then they're dependent. If it's the alternative, it's not dependent. So we failed to reject, right?
Mm-hmm.
We failed to reject, so we have insufficient evidence that it is independent of age.
Perfect. Yeah, because that's what I put.
Okay. Okay. Then I think this is where I got lost.
See, I didn't know what to do for these questions.
Okay. Well, it looks like we're able to put it into a test online because it has upper and lower bounds that we can put in. So a recent book noted that only 20%. Oh, I did do this. Wait a minute. I did do this. Okay. If you go to the one proportion test.
Okay.
Okay. A recent book noted that only 20% of all investment managers perform the Dow Jones Industrial Average over a 5-year period. Random sample of 200 investment managers. So we know that N is 200.
And then X?
X is 50 of these outperformed. So I think you put 50 at the top.
Okay.
Because it says that 50 outperformed. And our null hypothesis is 20%.
Oh, okay. And then type of test.
Well, it says a recent book noted that only 20% outperform, blah, blah, blah. What is the question here? Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed. So that would be greater than.
Okay.
I don't know if this is right. I did it.
So I think
like I did it.
The lower bound would be 0.190.
Yeah, but how come? Why am I not getting that?
What were the numbers that you?
I put in 50 for the 50 for the number of guys, and 200 for it, and confidence level is 9.95. Null hypothesis is 0.20. And
the type of test is greater than, right?
I think so, but I got the confidence interval as 0.001. But how is that possible? The first time I did it, I got 0.9190.
I got 0.19.
You got 0.001?
0.190.
How did I come up? All right, let me try this over again. So in X, we should have 50, right?
Mm-hmm.
Okay. And then in N, we should have 200, correct?
200. Uh-huh.
Then the confidence level is 0.95.
Yep.
Null hypothesis is 0.20.
Uh-huh. And then it's greater than.
But how come I got it different the first time? So you got C 0.190?
Yeah.
Uh-huh.
Why do I have the same numbers but different results as you? Did you do it under the one proportion test?
Yeah. Uh-huh.
Why do I have different? I can't figure it out.
Cassie, for the upper, did you get 0.310?
Yeah.
So what numbers do you have, Lori?
Hang on. I'm putting this back in again, just a second, because the first time I do it, I got the right answer according to what's in the textbook. That is so weird, guys.
That is weird.
I closed out Excel and I rebooted it and I put in the exact same numbers. And now I have the confidence interval of the lower bound of 0.190 and the upper of 0.310.
What the heck?
I don't know. That's weird. So I have the upper bound as
310.
0.310.
Perfect.
And the lower bound as 0.190.
Uh-huh.
Lost. The next one. Suppose you had been in charge of designing the study. What sample would be needed to construct a margin of error of 2% with 95% confidence? I have no idea. But I do have, according to the textbook, I've got answers.
Is this the one where times it have more than 10 or something?
Well, this says what sample size would be needed, right?
Yeah.
So the answers are either, instead of 200, our sample size would either need to be 2401, 1537, 16, or just greater than 30. Which that has nothing to do with it. So I know that the confidence level of 95% is 1.96.
Mm-hmm.
How do you, and margin of error, I have no idea how to calculate that.
Well, should we just skip it for now?
Do what?
Should we just skip it?
Or we can each put in an answer and see if it's right.
Okay, yeah, let's do that. So what question is this on the review, on the textbook one?
24 on the textbook one.
24? Okay, so I will put 2401.
Okay, Cassie, you put 1537.
Okay.
And I'll put 1801. I have no idea. I'll be right back. Okay. The next question is, which of the following pairs of hypotheses answering this question?
So be greater than. So would it be E?
Okay, suppose you wish to see if there is evidence that graduates of one of the top 10 business programs perform better than other investment managers. So and we're using the 0.20, I guess. So it would be P equals 0.2. P equals 0.2 would be the null. And
it'd be greater than 0.02.
Would be A, B, C, D, E.
Yeah. That's what I got. And 30. Isn't it A?
Yes. No, wait. Yes, it's 10, right? Not 5?
Yeah, it's 10.
Well, that's not true. Because if it's a chi test, it's 5.
But since we're doing the sample Z test, it's 10.
Okay.
Because in the Excel thing up there, it says 10 for the requirement.
Oh, you're brilliant. Okay, what is your test statistic?
Was it 1.334?
Huh? Where do you get that?
That's Z in the Excel thing.
1.768 is what I got.
I got 1.768 too.
Whoa, why am I so wrong? Where is that?
Under the Z value.
Yeah, I have 1.334.
What do you have for your confidence interval? Do you still have 0.190 and 0.31?
Yeah. What is your p-value?
0.039.
Because I have 0.091 for p-value. So why the heck is mine different?
Okay, you know what? When you do the type of test, that makes a difference. So are we doing greater than?
I have greater than.
That's what I have.
Okay, so I have p-value is 0.039 and t-test is 1.768.
I have the same, Lori.
Because for my p-value, I have 0.091.
Okay, look and see on your inputs, Alexis. Do you still have 50 at the top for X? 200 for N. This level of 0.95. Null hypothesis of 0.20.
Yep.
And greater than? Why would it be different? Okay, Alexis, you put in what you have, and we'll put in what we have, and we'll just see, okay? That's weird that you have something different. I had something different a while ago. So if the p-value is 0.039, Cassie, that's less than 0.05. So if the p is low, HO must go. So we reject the null hypothesis, which would be A. Alexis, what did you get for the p-value? She gone?
She might be.
Okay, let's keep going. This is killing me. Okay, use the following information to answer the next 6 questions. Oh, this is a SPSS thing. Computer software is commonly used to translate text from one language to another. Blah, blah, blah. We've already done this one. A blue score is a number ranging from 0 to 1. To compare Pharaoh's ability to translate with similar computer isolation hard software.
Sorry, mine went out again.
Okay, we need to get on SPSS for the next one.
So should I put in your guys' answer for the test statistic and p-value?
No, put in yours and let's see which one's right.
Okay. So for 33, did you guys do the very last one?
What do you mean the very last one?
Did you put A, B, C, D, E, F?
No, because our p-value is lower than 0.05.
Oh my gosh, why is that so different? I wonder if I should go back in Excel, kind of like what you did.
My gosh, I forgot how to do this SPSS crap.
I know.
Okay. I gotta figure out how to do this again.
Do we just do the one L20?
Oh my gosh. Okay, so I've got the BLEU thing up.
Yeah.
On SPSS. but can you remember how?
Did we just do the one sample t-test?
Mine's not working right now, so it won't open. So I'm gonna let you guys. Oh.
Okay, one sample t-test.
I would assume, but I'm like the least reliable person.
Hang on a second.
This is the longest quiz ever.
That's joy.
I sure wish that we what do you call it? Could record these, because I definitely would go back and look at people's.
Mm-hmm.
I know. If I'll like our videos to look back on when we knew what we were doing in the very beginning.
Assuming the requirements are satisfied, construct a 95% confidence interval.
So the one sample t-test brought that up. Did it bring it up for you?
Yeah. Okay, I think the confidence interval, I did a one sample t-test on it.
Mm-hmm.
And what is it asking?
For the lower bound.
The lower bound? Here, I'm going to tell it to you guys, so then you can tell it to me back. It's 0.282. Ah, crap. I lost it. Hang on. And is it asking for the upper?
Uh-huh.
0.293.
Yep.
And then what's the next one?
The degrees of freedom.
The degrees of freedom.
Okay, 99.
Yeah.
What's next?
The test statistic.
The test statistic is 109.091.
Yep.
109.091.
And then the p-value.
Well, the p-value is 0.000.
Okay. And based on the results of the test, what would you conclude? The level of significance is 0.05.
Okay, so the upper bound was 0.293 is what I told you, right?
Mm-hmm.
Uh-huh. So we have
the-
sufficient evidence, right?
Hang on, I'm putting in my stuff. Calculate the degrees of freedom. The test is the p-value of mu equals point. Wait a minute. Do I need to put in a test statistic of 0.295 then? Because I did not put in any kind of a test.
You're fine. We have all the answers.
The test value is what does it say? 0.295?
They're not asking for the test value.
No, look in the wording.
Which one?
Okay, look, it says right above question 36, it says calculate the degrees of freedom, the test statistic, and the p-value for a test of mu equals 0.25 against mu does not equal 0.25. Don't I have to put that into the test value?
Yes, I think.
Okay, so in that case, it's different, because if I put in the test value,
How do you do that?
It's on
Because
SPSS.
I think you do put in that value because that's kind of what we're testing.
Okay, so number 38, the p-value. If we go by that, the p-value is going to be 0.006.
Okay. And then is the upper and lower the same? Not upper and lower, sorry. Is the degrees of freedom?
The degree of freedom is not the same. Here's my problem, okay? They ask us all these questions up the top, and they ask for a lower and upper. And then all of a sudden, they tell us a test value.
So maybe.
So does the test value lower in the questions before they give us the?
No.
I think it changes after.
So frustrating. Huh?
Yes, I think it changes after that fact. So I think we leave the input, the upper and lower.
Okay, so after I put in the test value of 0.295, what are the questions? Degrees of freedom?
So the degrees of freedom.
99. The test value
test statistic?
Negative 2.803.
Wait, so what is it?
What is what?
The test statistic?
Negative 2.803.
Okay.
And the p-value is 0.006.
Okay.
But that's only if you put in the test value of 0.295.
Okay.
So that's what I'm going to put.
Yeah. Because if we didn't have to change it, I don't think they would have said that. So I think we're good.
All right. So on 39, P is lower. So if P is low, HO must go.
So it's sufficient.
So we are. Yes. We have sufficient evidence to say that the true mean is
different.
Wait a minute. I got it. The P is low, right? So it's the hypothesis. And when we reject the hypothesis, then we have insufficient evidence. Are you getting this?
So when we fail to reject, we have insufficient. When we reject, we have sufficient, right?
No. If P is low, the null has to go. So that means we reject the null hypothesis and we have insufficient evidence.
Oh, I wrote it down wrong then.
So wait a minute. If P is low, HO must go. So we're rejecting it, right? So if we reject the null hypothesis, then we have sufficient evidence. So we have, in this case, we have sufficient evidence to say that the true mean is different, right?
Yes, that's what. Yeah.
Okay. Oh, I literally hate this, you guys. I hate it with so much passion, I can't even tell you.
I know.
Okay, we're almost done. We're almost done.
Yay!
Okay. So the next one is a study was done to test the notion that people are taller when they first wake up in the morning than in the evening right before they go to bed. We've had this before. To test this theory, the heights of children in a boarding school in India were measured. Values were recorded. Blah, blah, blah. You want to determine if the children are taller in the morning than in the evening. So you take AM minus PM. So let's go to this, whatever this is, on SPSS. And I have to find the, and it's AP something. What is it? AP something height? AM PM height.
Mm-hmm.
So now what? I wish I knew what lesson this was from, because I have it in my notes under different lessons. Let me see if I can find it.
Yeah.
Okay. Okay, this is not a one sample t-test. This is
Independent. No, not independent.
I wrote down very specific notes on this, but I need to. Okay, wait, I think this is it. Okay, transform, compute variable. I don't know. Oh, this is so frustrating. If you guys were so nice, I'd cuss right now. Because you have to go in and you have to put AM minus PM, but how do we do that? Do we go into analyze, compare means, independent sample t-test, maybe? Okay, so we put, so what does it say wording, guys? Does it say PM minus AM or AM, PM? What does it say?
So it says AM minus PM.
I don't know. I'd really have to look it up because I don't know. It's on the SPSS stuff. Okay, when do we start doing SPSS stuff? Lesson
Well,
what?
I know we had on our last test.
But you guys know what I'm talking about? You have to go to some of these formulas and put in AM minus PM. But
Yeah, I know exactly what you're talking about. I'm trying to figure it out.
I don't think I've ever gotten one of those right.
Okay. We're just gonna have to hang on, I guess, for a minute because and I have to take dinner over to somebody. Okay, you know what? I can't stay on here anymore. I'm getting to.
So I think I found how to do it.
Okay.
I think I looked up on the internet. So to go analyze.
Okay, analyze. Analyze what compare means.
And then means.
No, I don't think it's just means.
Then this is wrong because this is like an SPS help. Wait, compare.
Well, maybe. Okay, so we're doing AM minus PM. Or PM minus AM.
AM minus PM. Wait, AM, yeah.
AM minus PM. I don't know if this is right or not. And what's it asking?
The lower bound, upper bound.
No, this isn't right.
Test statistic, and then degrees of freedom.
Nope, this isn't right. What you just told me doesn't even come with a upper and lower bound. So analyze, compare means.
Is this for the independent?
It should be independent sample.
Yeah. Okay, I'm gonna look again. 1 sec. Okay.
Notes on it, but I can't. I'm getting. I might have to jump off of here and then just work it out later until I find it and tell you guys. Okay.
Okay.
Well, I'm just going to go ahead and submit my quiz.
Okay.
With all, and then I didn't get. All right. Go through. Question number 2 is wrong. Question number 3 is wrong. Question number 4 is right. Question number 5 is right. Question number 6 is wrong. Question number 7 is wrong. Question number 8 is right. Question number, we failed this whole entire thing.
Wait, so we have 2, 3, 6, and 7 wrong so far, Cassie?
Yep, we have 2, 3. I'm just going to tell you the ones that are wrong, okay?
Okay.
6, 7, 9, 10, 14, 25, 28, and then I didn't answer the last several. So the ones that are wrong are
right.
Yeah, so the ones that are wrong are 2, 3, 6, 7, 9, 10, 14, 25, 28, And then I didn't do 40, so 40 on.
So, but like 39, like 30, like 29 to 39 is right?
Well, if I didn't say.
Okay.
29 is right. 31 is right. 32 is right. 33 is right. 34 is right.
Okay.
35 is right. 36 is right. 37 is right. 38 is right. And 39 is right.
And you said 14 was wrong too?
Yeah.
Let's see.
So 14 and 28 were the ones that we each took a number.
Okay. 14 and 28, we each took a number.
Yeah, so those ones we'll have to see what we each get.
Wait, what did you put on 14 and 28?
I put, for 14, I put 876. And for 28, I put 1801.
Okay.
And then what'd you put for 14?
876.
876.
Wait, sorry, you guys are like breaking up. What was 14? Or what'd you put for 14?
876.
Okay.
All right. I have to go. We've been on here an hour and a half. Over an hour and a half.
Ignore
I
all.
know.
Okay.
What's that?
I said
What,
you go have a
Cassie?
fun night. Have a fun night.
Yeah. Plus, I have another test to take tonight.
Oh,
So, if I get it figured out, or email each other if we get this figured out. I'm going to hop online tonight. See, the other hard thing is, for me, getting on that test review, it doesn't even start till 10:30 p.m. my time.
wow.
Really?
You should have those recorded, honestly. That's super dumb.
I think she is going to record them. But I'm going to listen to her, and then, because if I'm on live with her, I can ask questions like, how in the heck do we figure out what hypothesis test to use? This is ridiculous. So, all right.
All right.
3 more weeks.
Ah, we can do it, guys.
Watch the test review, because you can ask her questions online as we go along.
And for the collect the data, have we all put in our stuff?
I need to put in mine.
I haven't put in mine. I mean, I put it on this spreadsheet, but I haven't made out the thing yet, but I will.
Wait, we done the what yet?
You have to go online and answer the questions on the worksheet.
Oh, okay.
That's what you turn. Hi, honey. That's what you turn in.
Do we do?
And if we don't alter,
we'll do individually.
Don't alter, then we don't get credit.
Do we have to turn it all in? All of us?
Each of us has to turn in our own worksheet. I'll text you guys later about that, okay?
Sounds good.
I just can't do it right now.
Sounds good.
Okay.
Bye.
Bye.